it a dark gray color. Raylib provides several built-in colors, but we will be defining our own colors for this game. In Raylib, colors are represented using a struct called color, which contains 4 unsigned byte components: red, green, blue, and alpha. The values for each component range from 0 to 255, where 0 represents the absence of the color and 255 represents the full intensity of the color. For example, to create a red color, we will create a color struct with the following values. Color red is equal to curly brackets 255, 0, 0, 255. The first three values represent the red, green, and blue components, respectively, while the fourth value represents the alpha component, or the transparency of the color. In this case, the alpha value is set to 255, which means the color is completely opaque. So, to create a dark gray color, we will create a color struct like this. Color gray is equal to curly brackets 29, 29, 27, 255. Inside the game loop, before the endDrawing function, we call the clear background function. Clear background parenthesis gray. So when the clear background function is called, the Windows background is cleared with this gray color. This is typically done at the start of each frame of the game loop, so that the previous frame's graphics are wiped clean and the new frame can be drawn without any old artifacts or remnants. If we run the game now, we can see the game window is now gray. Beautiful. We just completed a very basic game loop, so we can remove step number 1 from our list. We have made progress. Now let's work on step number 2. To prepare for writing code, it is important to take a step back and think through the game logic thoroughly. In Space Invaders, we have several game items, including a player-controlled spaceship, descending alien invaders, and defensive obstacles. The goal is to protect the spaceship from being destroyed by the alien invaders while shooting them down to earn points. As the game progresses, the aliens descend closer, increasing the challenge. From time to time, a mystery ship appears, and the player can hit it to earn more points. Alongside the gameplay, there are also UI items such as displaying the player's score, lives, and the all-important high score. Mastering the coordination between player movement, shooting, and defending against the alien onslaught is the key to success in this classic arcade game. First, let's create a player-controlled spaceship. Let's go back to our code. We are going to use object-oriented programming to help us organize our code. We will create a spaceship class. As we are creating a separate class for our spaceship, we need to separate the declaration of the class and its implementation. That is where the header file and the implementation file come into play. The header file contains the class declaration, including the class name, member variables, and function prototypes. It serves as an interface for other parts of the program to use the class. On the other hand, the implementation file, usually with a .cpp extension, contains the actual implementation of the class functions. This is where the member functions defined in the header file are implemented. Separating the class declaration from its implementation allows for better organization and abstraction of code, making it easier to manage and maintain large projects. So we will need to create two new files to create the spaceship class. I press Ctrl+N to create a new file and then Ctrl+S to save it as spaceship.hpp. I will use the HPP extension to distinguish the C++ header files from the C header files which have the extension .h. Now we can start writing the header file for our spaceship class. Pragma once. This is an instruction that ensures that this header file is only included once in a compilation unit to avoid duplicate definitions. Now we can declare our class. Class, spaceship, curly brackets and a semicolon. Our class will have some public and some private methods. So let's add public here and private here. Now the first public method is going to be the constructor. So we type spaceship, parenthesis, and semicolon here. We also need a destructor. So we type tilde, spaceship, parenthesis, and semicolon. Now what are the basic methods we need for the spaceship? We need an update method to update the position of the spaceship on the screen, a draw method to draw the spaceship image on the screen, a move right and move left method to move the spaceship, and a fire laser method because the spaceship will be able to shoot lasers. So let's declare this method as public methods because other parts of the program will have to call them. Void draw parenthesis and semicolon. Void move left parenthesis. Void move right. And lastly, void fire laser. These are the basic methods that our spaceship class is going to have. We will add more as needed as we code our game, but these methods express the basic functionality of the spaceship. Now let's think about the attributes we're going to need. First of all, we're going to need an image. So let's create this attribute as private. We won't let any other class touch this image. We will use Raylib's texture2D data structure. So we need to include it here. Include raylib.h. Now let's create the attribute texture2D image. In Raylib, texture2D is a data structure representing a 2D image that can be used for rendering graphics. Next, we need to know the position where the spaceship is on the screen. So let's create a position attribute of type vector2. Vector2 position. In Raylib, vector2 is a data type representing a 2D point or vector with an x and y components. It is exactly what we need to represent the position of the spaceship. Now a basic version of the spaceship class is ready. Let's create the implementation file. One quick way to do it is to go to the unimplemented methods here. As you can see, VS Code notifies me that these methods are not yet implemented. Let's implement the constructor first. We can click on the Quick Fix button and then select the first option to create the .cpp file and the definition. Perfect. This saved us some time. Now in the constructor, the first thing we have to do is to load the image of the spaceship. I have placed all the images that we are going to use in this game in a folder named Graphics inside our game folder. You can download all the files from the GitHub repository linked in the video description. So let's load an image from the graphics folder. Image is equal to load texture, parentheses, quotes, graphics / spaceship.png. In this line, we load an image file named spaceship.png from the graphics directory, assuming it's in the same directory as your game script. This image will serve as the visual representation of our spaceship in the game. We use the load texture function to load the image and then assign it to the image attribute. Every time we